In this video, we want to start looking at how do we find zeros of polynomials. So what exactly do we mean by the zero of the polynomial? So if we were thinking about the graph of the polynomial, so it could be any general polynomial, maybe it just looks something like this. What we mean by zeros is we mean the place where y is equal to 0. So in other words, the x-intercepts. Right, so these 3 points right here in this case. So we want to look for the places where f of x is equal to 0. So these points are of a lot of practical importance. A lot of practical situations call for these points, and we'll need these points a lot in calculus for different purposes there. So they're kind of used all over the place. So it's important to be able to find these points, these zeros. They're also sometimes called the roots. So in general, we say that r, maybe x equals r, is a root or 0 of f if f of r equals 0. Okay, so in the linear case, this is pretty simple. We just solve the equation. Like if f of x equals x minus 5, right? Then we just set this equal to 0. We set this equal to 0, and we say add 5 to both sides, and we get x equals 5. Right, so we confirm that 5 is a 0 of x minus 5, and we can confirm it by actually plugging it in and making sure it works. Right, so sometimes you might be given a root, asks to confirm that it is a root. All you do is plug it in and make sure you get 0. Okay. So with some polynomials, it's set up so that we can just easily solve it just using algebra. For example, maybe we have something like x minus 2 squared plus 4 equals, or we get this function, right? And we want to find the 0 of it, so we set it equal to 0, and then we can just solve for it. Okay. Now in this case, what happens is that we get this, x minus 2 squared is equal to negative 4, and that's actually not possible, right? If something's squared, it can't be a negative number. And if you try to take the square root of both sides, it won't work. And if we remember our graph transformations, this is x squared moved to the right 2, up 4. So its vertex is going to be at 2, 4. It's going to be up there. So we can clearly see graphically it doesn't cross the x-axis either. So it makes sense that we would get no solution for this. So a polynomial does not have to have zeros. If we alter it slightly, x minus, or maybe x plus 2 squared minus 4 equals 0. Okay, now if we think about what this graph would look like, I'll do it in a different color here. It's going to be moved to the left 2 and down 4. Actually, so that's not going to have any zeros either, right? Because it's, oh no, I'm sorry. It's still opening upwards. My mistake. I was thinking it would open downwards for some reason, but no, it will still open upwards. So, but it's just the graph of x squared. It's not being reflected at all. It's just moving to the left 2 and down 4. So we can see there are 2 points where it's going to hit the x-axis. So it should have 2 zeros. So we'll just try normal algebra. Add 4 to both sides. X plus 2 squared equals 4. Now this is something we really haven't come across yet. When we take the square root of both sides, when we're doing it in the context of an equation, we have to consider both the positive and the negative solutions here, because we're going to get two solutions. You can see right on the graph here, we're going to get two solutions. Okay, so we're going to break this into two cases, right? First, x plus 2 equals 4, and x plus 2 equals negative 4. Or, I'm sorry, 2 and negative 2, because the square root is 2. But the idea is that 2 squared is 4, and negative 2 squared is also 4. So we have to consider both of these in this context. So on the top here, we get x equals 0, which shows how badly drawn my graph is here. And here we get x equals negative 4. Okay, so this can actually help a lot in drawing the graph. So we can go ahead and make it better based on our new information here. So we have a point at 0 and negative 4. So it should look like this. Okay. Okay, so this is called solving by the square root property sometimes, or just directly solving. Oftentimes though, when we're looking at quadratics, they're in that kind of trinomial form like this, right? And so we really can't directly solve this. And that's because we can't really get x by itself in this context, right? Because there's an x in two different terms. So there's no way for us to really isolate the x. So this is where the factoring comes into play, and that's why we looked at factoring. Okay. So if we first factor this, so we're going to set it equal to 0. Okay, but if we first factor it, we say, okay, x plus 4, x plus 1, we already did this one in the previous video, is equal to 0. Then there's something called the zero product rule. Okay, I'm going to write this on the side here. The zero product rule. And this says if a times b equals 0, then a equals 0 or b equals 0. Okay, assuming we're working with the real numbers, of course. So it's just something that if you think about it, it should make sense. Like if you multiply any two numbers, you're not going to get 0 unless one of those numbers is 0. So here, that's what we're doing, right? We're taking the product of x plus 4 and x plus 1, and we're setting it equal to 0. So we should, we know that either x plus 4 is 0 or x plus 1 is 0 because their product is 0. So we use that to our advantage here. We say, okay, then x plus 4 is 0 or x plus 1 is 0. Okay, so x is negative 4 and x is negative 1, and these are the two zeros. Okay. So in general with quadratics, we'll get two zeros or no zeros. You can kind of tell from the graph, right? In this case, we had no zeros. In this case, we had two zeros. We could get exactly 1 0 if it's sitting on the x-axis, like on x squared's case, for example. The only 0 is 0 itself. Now we're completely relying on the fact that it is factorable, first of all, right now. We can imagine a case where something's not factorable. You know, if something is like x squared plus x plus 1, the only factors of 1 are 1 and 1, or negative 1 and negative 1, and both of those add to 2. So this isn't factorable, so this isn't really something that we can solve using this method. So we're only looking at cases where things are factorable right now, which admittedly is pretty limiting, but it's good to look at these first. Okay, so let's say we have f of x equals, or maybe if we just take it out of the context of a function for a second, sometimes maybe we'll get an equation that looks like this. Okay, something like this. and where one of the sides is not 0. So if you're trying to solve something like this, it's important. The only reason I want to mention this is because sometimes we'll kind of fall into the trap of like factoring, and we might write x times x minus 13 equals negative 30. So x equals negative 30, or x minus 13 equals negative 30. But that's just not true, right? We need the right side here. We need it to be equal to 0, because the 0 product rule only works if the product is 0, right? Not if the product is negative 30 or whatever. The product of two numbers being negative 30 does not imply that one of them has to be negative 30, which is what we're saying here. So this is another common trap that we might fall into. Like if you're just doing these a lot and you just kind of forget to make one side equal to 0. So the proper way to do this would be bringing everything over to one side first, so it is equal to 0, and then factor it, right? So you get x minus 10, x minus 3 equals 0. So x equals 10 and x equals 3. Okay. So we want to bring everything to one side, make sure that one of the sides is 0 so that we can employ the 0 product rule. So now if we do another example, we're not limited to quadratics here, but we are kind of limited in the forms of things that we can factor, right? So maybe we have something like this: x to the 4th minus 1 equals 0. Well, this we might recognize as the difference of two squares, right? X to the 4th is x squared squared. Okay, so this is x squared minus 1. Well, of course, 1 squared is 1 squared is 1 as well, times x squared plus 1. Okay, and now x squared minus 1, that can also be further factored into x plus 1, x minus 1, using the difference of two squares again. So we get this whole row of things that is equal to 0. The 0 product rule can extend to more than two factors as well. So we can say all of these are equal to 0. X plus 1 is 0, x minus 1 is 0, x squared plus 1 is 0. Okay. Now this last one, x squared plus 1 equals 0, that's not ever going to be true. If you just think about the graph, that's the x squared graph moved up 1, so it's not ever going to cross the x-axis. If you think about it algebraically, this is x squared equals negative 1, which is impossible, so we can ignore that one. And we get x equals 1, x equals minus 1. Okay. So we're not limited to just quadratics, but we are limited to things that we can factor, essentially. Okay. So now if we maybe have one like 2x cubed plus 10x squared plus 6x. Okay, set this equal to 0. So now maybe we look for a common factor, and we might see that everything has a 2x in it. So we can pull a 2x out of everything. So we get x squared plus 5x plus 3. I actually meant for this to be 6. I don't think it's factorable how I wrote it. So let's alter it real quick. That should be 12x, so that when we factor it, it's 6. Okay. The first way I had it written wouldn't have been factorable. So now we can factor the quadratic. We need to keep this 2x on the side here. If it's just a number, we don't need to keep it, right? Because we could just divide both sides by 2. And in fact, we could divide both sides by 2 right now. And that's fine. We can't divide both sides by x because then we lose one of our factors. But we could divide both sides by 2, so we don't need to worry about the number part over there. But now, so the 2 just kind of gets absorbed because this is 0 divided by 2, which is 0. So it makes no difference on the zeros. So now we factor this middle part. We get x plus 3, x plus 2. And now we set all 3 factors equal to 0. So x equals 0, nothing to do there. X plus 3 equals 0. X plus 2 equals 0. So x equals -3, x equals -2.